discuss one upper atmospheric circulation, that is jet streams. Now, one of our common observations regarding upper air circulation is the movement or drift of clouds. This movement is sometimes fast and sometimes slow, which indicates that air moves in the upper troposphere also. Before World War II, upper air observations on scientific basis were very limited. Most of the observations were based on the limited data coming from volcanic eruptions, the balloons, aircrafts, as well as satellite images. And they have provided a great deal of idea as well as data to prove the existence of upper air movement, particularly after the World War II. Now, jet streams was first experienced by the pilots of jet planes of USA during the World War II. The American bomber pilots tried to fly towards Japan at an altitude of around 13,000 meters, and during their journey towards Japan, they encountered strong headwinds which produced them great resistance to forward movement, and this resistance basically influenced their speed. They basically slow down the speed of the jet planes. In contrast, during returning to America towards east, they found that the speed of the jet planes becomes much faster, because during that time the wind movements facing the tail of the jet planes, so that basically favors the movement of the jets, and due to that the jet planes take much shorter time to return to their base. So jet streams are found in the upper troposphere, and they are basically fast flowing band of long, narrow, high speed winds near the tropopause. These are basically the geostrophic wind blowing from west to east. The jet streams found high up in the atmosphere, where there is large temperature difference between two adjacent air masses. So one air mass must be of warm condition, and the other air mass must be of cold, denser air mass. The meandering or the wheel movement of the jet stream is called Rossby wave. Now on Earth, there are four main jet streams found to occur: two polar jet streams and two subtropical jet streams. So one for each hemisphere, one polar and one subtropical jet stream for the northern hemisphere, and for the southern hemisphere again one polar jet stream and one subtropical jet stream. These jet streams form in the atmosphere where warm air masses meet cool air masses. Now coming to the types of jet stream. In nature, mainly two main types of jet streams are found. One or first is the subtropical jet stream, and the second one is the polar front jet stream. The subtropical jet streams used to develop during winter and early spring seasons. These jets give predominantly fair weather in areas they pass over, and sometimes they used to drift northward and merge with a polar front jet. The subtropical jet streams are produced due to Coriolis force and temperature difference between tropical and subtropical regions, where the velocity of the Earth's rotation produces a greatest deflective force in the atmosphere. As a result of this rotation, the rising air deflected to the right in the northern hemisphere and to the left in the southern hemisphere at about 30-degree latitude, which spreads out northwards and southwards. During winter, nearly continuous subtropical jet streams are produced in both the hemispheres, which exist in the southern hemisphere all the years, whereas intermittent in the northern hemisphere, and during summer it migrates to further northern side. Next, the polar jet streams, or also known as polar front jet streams. Polar front jet streams is also called as mid-latitude jet streams. These jet streams occurs in a belt of world's most powerful upper level wind force, moves generally in westerly direction and forms in the junction between the Ferrel cell and the polar cells. So this jet streams occurs at around 60° north and south latitudes. As a consequence of formation of these jets manifest themselves as fronts which are very much unstable. In summer, the position of this jet stream shifts towards the poles, and in winter it shifts towards the equator. In winter, jets are stronger and more continuous. It greatly influences the temperature difference of two different air masses lying close to 50° or 60° north and southern hemispheric regions, where the polar jet is actually located. This jet stream determines the path, speed, and intensity of temperate cyclones. Now, these two, the subtropical jet stream and the polar jet stream, these are also known as permanent jet streams. Apart from these permanent jet streams, there are some temporary jet streams, and these temporary jet streams formed when wind speeds crossed over 94 km per hour in the upper atmosphere at around 9 to 14.5 km above the ground surface. Most important of this temporary jet stream is the polar night jet stream, or it is abbreviated as PNJS. It is This polar night jet stream is also known as the stratospheric subpolar jet stream, and it is developed at the height of 30 km during winter. It becomes very strong due to steep temperature variations in the stratosphere around the poles and moves westerly, but the velocity decreases during summers and the direction becomes easterly. Here, in this satellite image taken from GOES 16, you can see the southern green area is basically the warm, moist tropical air, while the northern red or orange colored area is basically consisting the cold, dry polar air. And in between these two winds, you can see a very narrow band of whitish or bluish color which is moving from west to east, and this wind is very fast flowing narrow band between the uh, two adjacent different characters bearing winds. The southern one is the warm wind and the northern one is the cold wind, and in between this narrow band is the polar jet stream. Now, one interesting phenomenon found for jet stream, that is the index cycle of jet stream. The index cycle of jet stream represents the change from straight path to most sinus path of the jet streams. As you can see in this figure, the figure 1, that is showing the most straight jet stream, and with simultaneous development the straight path is becomes curved and simultaneously it becomes more and more meandering, as you see in figure 3 and figure 4. Now these transformations from straight path to most meandering takes place in about 4 to 6 weeks and is normally divided into four successive stages or four successive phases. In the first stage, the jet stream prevails near the pole and occupies a general west to east direction. It operates in polar front zone, and the presence of cold polar air mass in north and warm tropical air mass in south in northern hemisphere without any undulations or little undulations. That is why the path of the jet stream is more or less straight. The polar front in a fairly smooth condition and stable. The steep pressure gradient and consequent high velocity jet streams prevail west to east in the strongly established upper air westerly circulation. At this stage, near Earth's surface, in mid and high latitude westerlies, as planetary winds are strong, zonal and slightly poleward, this stage is also known as stage of high zonal index because you can see the warm tropical air are restricted in the southern part and cold polar air is restricted in the northern part. So latitudinally they are distinctly separated. That is why the zonal index is very high. The pressure systems are oriented as zonal, that is in east-west direction in particular latitudinal zone. The latitudinal heat exchange is limited and cyclonic activity is prevalent in high latitudes only. In the second stage, the straight path of jet stream changes to undulating or wavy path, which means the amplitude of the jet stream increases and it starts shifting gradually towards equator. The minor undulations deepen gradually. The cold air makes inroads towards equator and warm air towards higher latitudes, towards the polar areas. In the third stage, in this picture, you can see the path of jet streams becomes more meandering and its amplitude registers significant increase. You can see the path is more meandering and amplitude is very high. Jet stream moves towards the equator and operate up to 20-degree latitude. The pressure gradient, which was equatorward to poleward in previous two stages, become west to east in this stage. Here you can see this one is at the same latitude. This is the cold air and again at the same latitude this is the warm air. So definitely there is a pressure difference in the warm air region, that is low pressure zone, whereas in the cold air region that is the high pressure zone. So the previously the pressure difference in picture 1, which was mm, north to south or meridional, now in the third stage this pressure difference becomes latitudinal. Large-scale latitudinal heat exchange therefore occurs due to the movement of cold air mass towards equator and warm air masses towards poles. The cold air makes inroads into lower latitudes in deep embayments which emerge as troughs of low pressure at high levels. Correspondingly, high pressure ridges are created by the intrusion of tropical warm air in embayments between the troughs. This stage is associated with outbreak of temperate cyclones near the surface. In the fourth and last stage, that is the final stage of jet stream index, the meanders are at its peak and the amplitude of the Rossby waves increases so intensely that large pools of warm tropical air are cut off and isolated in mid to high latitudes. Similarly, large masses of cold air are trapped in lower latitudes. You can see this cold air is cut off and trapped within the warm um, air of low latitudes, whereas this warm air is cut off and trapped by the cold dense air in the high latitudes. That is why this stage is also known as low zonal index stage. In this stage, low zonal index, north-south contrast of weather conditions and wind speed are minimum. The pressure systems and frontal systems are oriented in meridional position, that is from north to south or south to north. Therefore, the zonal character of upper level westerlies, which is found in the first stage, that gets fragmented into a number of cells. Now, the importance of jet stream is noteworthy that in the final stage, the detached masses of cold air become cut-off lows, which are cyclones in the upper troposphere. Likewise, warm air embayments also get detached to form cut-off highs as upper air anticyclones. This cut-offs process helps in latitudinal heat transfer and plays a vital role in maintaining the global heat balance. The influence or importance of jet streams on weather conditions. The jet streams helps in maintaining the latitudinal heat balance by mass exchange of air and influence the mid-latitude weather disturbances. When jet streams are interfering with surface, wind systems cause severe storms. Jet streams influence the path of temperate cyclones, thereby influence the distribution of precipitation. Also, an influence on movement of air masses is observed which may cause prolonged drought or flood conditions over the Earth system. Example of this is the polar vortex cold wave over North America in 2004 winters. The main importance of jet streams that during its final stage we already see in the previous figure that some air masses from the polar areas, that is the cold dense air masses, they get detached and uh, locked or trapped in the lower latitudes in the upper atmosphere, whereas some warm air masses, they get detached from their parent body and get trapped in the higher latitudes in the upper atmosphere. And due to this, the heat from the lower latitudes that is transferred towards higher latitudes, whereas the cold uh, wind that is transferred to lower latitudes. So there is jet streams are a major uh, tool for maintaining the global heat balance in the atmosphere. That's a brief idea about jet stream. Hope this will help you. Thank you.